So, hi guys, welcome to lesson 8 of geography series. Yeah, in this lesson we are going to learn about exogenic process. Okay, in previous class we have learned about endogenic process that happens interior of the earth, that is in the crustal portion, which results in the formation of continents and fold mountains and many other landforms like plateaus. Okay, now we are going to learn about exogenic process. Exogenic process. See, this exogenic process, it contains many important statements, words, and all. So, in this class, what I have done was I have picked the PDF form of the chapter from Physical Geography, Chapter 6, Class 11 NCERT, and then I will try to explain the entire exogenic process like mass, moment, weathering, and erosion by highlighting those statements and words in the textbook itself. Okay, so that it helps you to remember those statements for a longer period of time. Okay, so you also keep your textbooks with you while listening to this class, and also keep an atlas with you also. Okay, we will look at some places while explaining this, right? So exogenic process, what is exogenic process? Exogenic process is nothing but uh, the geomorphic process that occurs on surface of earth. Okay, exogenic process is nothing but it is a geomorphic process, that is it results in the physical changes on the surface of the earth, on the surface. Okay, that not interior, not it is on the surface, exogenic. Okay, uh, these exogenic process, they are of three types. They are weathering, mass movement, and erosion. Okay, exogenic process are of three types. They are weathering, mass movement, and erosion. All right, all these three process derive their energy from the atmosphere itself. Okay, from the atmosphere they derive their energy. For weathering to happen or mass movement to happen, it needs some kind of energy, right? That energy is derived from the atmosphere itself. Look at here, you can see the exogenic process derive their energy from atmosphere, determined by ultimate energy from the sun, and also gradients created by the tectonic factors. Okay, the exogenic process derive their energy from atmosphere. The energy in the atmosphere is determined by what? Okay, derive their energy from the atmosphere, and energy in the atmosphere is determined by sunlight itself. Depending upon the amount of sunlight we receive, the speed of the winds is determined, the amount of precipitation we get is determined. Okay, so sun is one of the factor to determine the energy behind this exogenic process. And second one is the gradient. I have told you what is gradient. Gradient means difference. Okay, gradients created by tectonic factors. Due to tectonic factors, that is due to plate movements, some relief features are formed on the earth in the form of rocks and mountains. Okay, they have gradient like slope. Some have gentle slope, some have steep slope, so that there is difference occurring based on the slope. So if the slope is very vertical, we can see movement of the materials in a fast manner. If the slope is gentle, we can see the movement of the particles or earth materials in a slow manner. Okay. So and this gradient is developed by tectonic factors. Okay. If the gradient is more, the gravitational force will be more. More will be the attraction from the gravity, so that the material falls with a much rapid force. Okay. Yeah. Next. See, the basic reason that leads to weathering mass movement and erosion is development of stress in the body of the earth materials. See, body of the earth material is nothing but rocks. Okay, the basic reason that leads to weathering, mass movement and erosion is development of stress on the earth material. That is development of the stress on the rocks. Okay, earth materials nothing but rocks. Okay, development of the stress. What is stress? Stress means force applied on a unit area. Okay, let's say, yeah, wait a minute. Yeah, let's say it is a rock, a square shaped rock. Imagine it is a square shaped rock. Okay, it has certain area, right? I applied some force on only one part of the rock, on a unit area, not entire area, on a unit area. I applied force. Okay, this force applied on a unit area develops stress in this rock material. Okay, due to development of the stress, cracks are formed on this rock material. Okay, once the cracks are formed, it is easily deformed or denuded. Okay, so the basic reason behind weathering, mass movement and erosion is development of the stress. Stress means force applied per unit area on the rock. Okay, yeah. And next, what are the different types of forces that are or stresses that has been applied on the earth material? They are gravitational stress. Okay, and molecular stress. Right, the different type of stresses that get applied on those earth materials or rocks are of gravitational stress and molecular stress. Gravitational stress, you all know, uh, on the on the rocks of the earth, gravity exerts some force. Okay, due to the that exerting of pressure by the gravity, stresses are developed on the rocks. That is gravitational stress. And secondly, molecular stress. Molecular stress can be, like, it can be developed by temperature changes. Okay, see, if there is a certain earth material or a certain rock, due to high amount of temperature it can expand. Okay, due to low temperatures it can contract. Due to this expansion and contraction, cracks are developed on the earth material. That is, the bonds between the molecules is loosened. Okay, which results in the chemical decomposition of that earth material. That is molecular stress. Okay, yes. And this geomorphic process are controlled by two climatic factors, that are temperature and precipitation. Precipitation means rainfall. Okay, two important climatic elements control exogenic geomorphic process, that is temperature and precipitation. How temperature and, okay, you know uh, temperature and precipitation controls these exogenic process. We will look into it one by one. Okay, see, the word denude means to strip off or to uncover. All geomorphic processes are covered under a general term called denudation. All geomorphic process, that is weathering or mass movement or erosion, results in only one thing, that is denudation. Denudation means stripping off the layers of a material is called as denuding. Okay, and the energy behind see, I have told here, the exogenic process derive their energy from either atmosphere, that is sunlight, or gradients developed due to tectonic factors. Okay, uh, uh, with respect to these two, different kinds of energy is responsible for different type of geomorphic exogenic process. Okay, for example, for weathering, sorry, for weathering, the driving force or energy that is required for weathering to happen is gravitational stress, molecular or chemical action. Molecular stress or chemical action are one and the same. Okay, even in chemical action also there will be loosening of bonds between the molecules, and thereby the chemical composition of the material changes in weathering. Or weathering can also happen due to gravitational stress also. Okay, and mass movement, for mass movement it is solely only gravitational force, not gravitational stress. Gravitational force, that is gravitational force attract the earth material, and that earth material moves along the gravity towards the gravity. So gravity force is responsible for mass movement, and kinetic energy is responsible for erosion or transportation. What is kinetic energy? See, any moving body possesses kinetic energy. For example, a car that is moving, it possesses kinetic energy. Likewise, in previous class, we have talked about geomorphic agents like wind, waves, ocean currents, running water, etc. So, a geomorphic agent, that is, if a running water has high amount of speed, it has high kinetic energy. More is the kinetic energy, more is the erosion. Okay, so more is the speed of the water, more it can erode the materials in the area that is covering. Okay, more is the force of the water, more is the erosion. So more is the force of the water, more is the kinetic energy. So that's why kinetic energy is responsible for more kinetic energy is needed for erosion to happen. So these are the driving forces behind the all the three exogenic processes. Okay, yes. So we have told exogenic processes are weathering, mass movement, and what is this erosion. So are they uniform on the entire earth? No, they do not operate uniformly on the entire earth. Okay, because there are different climatic regions on the earth. Equatorial climatic region and tundra climatic region we have. Okay, and temperate climatic region we have. So there are different climatic regions on the earth, and base, so different climatic regions, there are different temperatures and different precipitations. So as these exogenic processes are controlled by temperature, precipitation, we have read previously that temperature and precipitation controls the action of this exogenic process. So in different climatic regions we have different amounts of temperature and precipitation. So these exogenic processes do not operate uniformly on the entire earth. They vary from climatic region to climatic region. Okay, because why they vary, I have just now said there are variations in thermal gradients, that is variations in temperature from climatic region to climatic region. Okay, there is a difference in amount of land and water also, and the type of vegetation distribution, that is the density, type and distribution of vegetation. Vegetation is nothing but forest. Okay, the amount of forest that is present in each climatic region also differs. So based upon it also exogenic process operate. If a certain area has a large amount of vegetation, it is quite difficult for mass movements to happen, because these plants or trees that are present in that area holds that soil with those strong roots, which is hard to erode. Okay, so if we have more vegetation, it is hard to erode the soil particle. If you have less vegetation, the less roots means less holding capacity, so it is easily to erode in areas where there is less vegetation. Okay, next. Even within these different climatic zones also, that is within different climatic regions, there may be local variations of the effects of the different climatic elements due to altitudinal difference, aspect variations, and variation in the amount of insolation received by the slopes. Okay, even within the same climatic region also, the rate of operation of what these exogenic process vary within the climatic regions also, because of the relief features. Some are very high, some are very low, some have steep slope, some have gentle slope. Some relief features may get more amount of sunlight, some relief features may get less amount of the sunlight. Okay, for example, if we take India, more landslides are you know are present in Himalayan regions compared to our Western Ghats region in the south. Why? Because compared to Western Ghat regions, Himalayas are very slope. Compared to Western Ghat regions, Himalayan rocks are made up of, you know, very uh, very less dense material compared to Western Ghat rocks are more dense, so that they are uh, much stronger than the Himalayan rocks. So we can see more landslides in Himalayan regions. See, within the climatic regions also, these exogenic processes operate differently. They operate differently from climatic region to climatic region. They also operate differently within the same climatic region. Okay. And what is this para is saying? Climatic factors being equal, the intensity of action of exogenic geomorphic process depends upon type and structure of rocks. Okay. Um, let's say within the same climatic region, or in between different climatic regions, the climatic factors, that is temperature and precipitation, are same. Let's imagine they are same. Even though those climatic factors are same, the mode of operation of geomorphic exogenic process differ, because it also depends upon the type and structure of the rocks. So these exogenic process acts on different types of earth materials or rocks. Some may be thin, some may be thick, some may have loose bonded molecules, some may have strong bonded molecules. So depending upon the earth material also, this geomorphic process operate differently. Okay, so exogenic process operate differently from climatic region to climatic region. Exogenic process operate differently within the same climatic region. Okay, even though the climatic factors are equal, they operate differently because these exogenic processes also depend upon the type and structure of the rock. Okay, yeah. So that's what it is saying. Under varying climatic conditions, particular rocks may exhibit different degrees of resistance to geomorphic process, and hence they operate at differential rates and give rise to differences in the topography. Topography means physical arrangement. Okay, the physical arrangement of the rocks. In some areas they might be continuous. In some areas they might be discontinuous. Okay. If you, the best example would be Western Ghats and Eastern Ghats. If you see Western Ghats, they are continuous from Maharashtra to Kerala. There is no gap between them. If you see Eastern Ghats, they extend from Orissa to Tamil Nadu. Give me a minute. Sorry. Where am I? Yeah, Eastern Ghats. Eastern Ghats extend from Orissa to Tamil Nadu, but there are many discontinuous. They are not continuous. There are breaks at certain points. Okay. So why? Because different types of rock materials offer different degree of resistance. Degree of resistance means variations in the resistance. Okay, some might have high degree of resistance. That is, they give more resistant to exogenic process. Some have low degree of resistance. That is, they have less resistance to exogenic process. So even though climatic conditions differ, but same type of rocks also climatic conditions differ for particular types of rocks. That is, same type of rocks offer different amount of resistance to exogenic process. So there is difference in the topography, that is physical arrangement of those rocks. If the rocks are different, then it is another story. Because previously I have explained, if the rocks are different, exogenic process operate differently. But if same type of rock also, the topography differs. That is, the physical arrangement of the rocks differ. Okay? Western Ghats and Eastern Ghats are almost made up of similar type of rock only, but their physical arrangement is different because they each type of rock offer different type of resistance to the exogenic process. Okay? Yeah. And the effect of most of the exogenic geomorphic processes are small and slow and may be imperceptible in a short time, but will in long run affect the rocks severely due to continual fatigue. Okay? These exogenic processes, that is weathering, mass movement and erosion, operate on the rock materials continuously. So the change made by those exogenic process is very slow. Okay? It keeps on happening for millions of years. Okay? And it is imperceptible. That is, we cannot see the change. See, for a rock to become from a steep slope to gentle slope, some hundreds of years takes for it to become like that. Okay, so it is impossible. We cannot see the change, but it happens slowly because of the continued fatigue. That is, continued operation of those exogenic process on that material. The process is slow, but it happens. Yeah. We look into the exogenic process. First one is weathering. Weathering is nothing but it is mechanical disintegration and chemical decomposition of rocks through actions of various elements of weather and climate. Weathering is defined as mechanical disintegration. That is, the mechanical disintegration is nothing but physical disintegration. Physical. That is, rocks have many layers, right? It have many layers. So these layers get disintegrated. Okay, we have studied denudation. These layers get stripped off. It is called as mechanical disintegration. And also weathering also means not only mechanical disintegration but also chemical decomposition. Every material has its own chemical composition, right? So the chemical compositions get disrupted and the chemical decomposition happens. Whenever the chemical decomposition happens, the chemical nature of the material changes. Okay, so weathering results in mechanical disintegration and also chemical decomposition through actions of various elements of weather and climate. Various elements of weather and climate means temperature and rainfall. Through these, not temperature and rainfall are the basic things. Due to many elements of weather and climate means, it depends on the sun, water, and also air, composition of the air and all. And this is most important, as very little or no motion of materials takes place in weathering. It is an in situ or on-site process. See, what happens in weathering? There is no transportation of materials. Okay, the material just gets disintegrated. Okay, the layers of the materials might get deformed or stripped off, or the chemical nature of the material itself changes. Okay, there is no transportation of the material. So it is the motion, that is, the materials don't move, or there might be only little movement of the materials. So it is an on-site process, happens on that site only. It does not move from one side to another side. So it is either on-site or in situ process. See, in different regions, we have different amounts of temperature and pressure. That is different climatic factors. So, weathering process differ from climate to climate. Not only the weathering process differs from climate to climate, but also depth of the weathering mantle. Weathering mantle means it is product of weathering. that is not subjected to transport. Okay, weathering mantle means it is the product of weathering. After weathering happens, we have certain we can see after weathering took place, we can see that the final earth material. Okay, that product or result of weathering, there will be a final product that is nothing but the weathering mantle. It should not be transported. It should be on that site only. Okay, if it is not transported, the product of weathering that is not transported is called as a weathering mantle. So what is it saying? Weathering process differs from climate to climate, but also depth of the weathering mantle also differs from climate to climate. How much weathering happens also differs from climate to climate, and it is clearly mentioned in this diagram or figure or graph per se. See, on y-axis, wait, I think it is clear for you. Okay, please see it in your textbooks and then learn through. Okay, I will explain it here. On y-axis we have precipitation and temperature Okay, see, they have given different climatic zones. Tropical forest, from it extends from equator to up to 10-degree north and south latitudes. Okay, savanna is nothing but semi-arid grassland. Semi-arid means semi-desert, semi-dry conditions are called as savanna. Savanna grasslands we call them. They extend from 10 to 15-degree north and south. Semi-desert and desert areas extend from 50 to 30 degrees north and south. If you take your atlas and see different types of deserts, for example, if you take deserts in Africa, like your Sahara, okay, and next within Africa only, Namib Desert, Kalahari Desert, and when it comes to northern hemisphere, we can see Arabian Desert, our Thar Desert, and in Australia it's Victoria Desert. These all are present in that 15 to 30 degrees latitudinal range only. Okay, once you observe these deserts in your atlas and mark them properly. Okay, there are some exceptions to deserts also. For example, in South America we have Patagonia Desert, which is almost on the southern tip of the South America, that extends beyond 40 degrees south latitude, and there are local conditions that are responsible for it, and I will explain when we get into the climatology. It would be very interesting. And steppes are grasslands. They are very thick grasslands. Okay, not semi-arid like savanna. They are very thick grasslands, and we can see them mostly in Central Asian region and Mongolian region, north through China. Okay, they extend from 30 to 45 degrees. And taiga podsol region. Taiga region means it is characterized by coniferous forest. Coniferous forest means the trees are cone shaped like this. Okay, it extends from 45 to 55 or 60. And tundra region up to some 65 to 75 degrees. Okay, yeah. Now observe carefully. Okay, see, precipitation is very less in tundra region, that is less rainfall in tundra region, and it gradually increased in around 45 to 55 degrees north or south latitude. That is in the taiga podsol zone. Podsol means it is the name of the soil. Don't get confused with these names. You will get accommodated with these names once we get into the climatology. So precipitation gradually increased here, and again decreased in the steppes region. Okay, and further decreased in the desert region, and from here it gradually increased that is some 10 to 15 degrees latitudinal range, and more rainfall at equatorial region. So if you see the areas where there is more number of large amount of precipitation, like taiga, podsol and your tropical forest region, we can see the weathering mantle has more layers. That is, weathering happened for very deep part. Okay, weathering happened very deep. Here see, one is fresh rock. Fresh rock will be in the like under the ground. So the weathering can happen up to fresh rock also. From 6 is your soil. From soil, we have different zones, and at the base you have the fresh rock. That is the rock that is responsible for the this soil formation. You will see at the bottom. In tropical regions, that is tropical forest zone, in equatorial region, you have high amount of precipitation, that is high amount of rainfall, which is much responsible for the weathering of deeper layers of the soil. Okay, in taiga podsol region also you have high amount of rainfall, which is responsible for weathering of the deep layers of the soil. In tundra region you have very less precipitation, so the bedrock remains as that. Okay, there is no weathering of the bedrock and formation of the soil, all that kind of things. So very less precipitation in the tundra region, so the bedrock remains like that. Very less amount of weathering we can see in tundra, and high amount can be seen in taiga region and your tropical forest zone, and even in semi-arid desert also. See, very less amount of weathering can take place. Okay, yeah. And next, temperatures. See, temperature also like this. From tundra to tropical regions, we see high amount of temperatures. So high amount of temperatures means more sun rays. Okay, more sun rays means the more the particles, the earth materials can expand. So more cracks developed, more chances for the weathering to take place. Okay, yeah. This weathering process is of 3 types. Okay, there are 3 major groups of weathering. Weathering process can occur through 3 ways. That is chemical weathering, physical or mechanical weathering, biological weathering. Let's look into chemical. Chemical weathering. See, chemical weathering is nothing but the operation of chemical process. Operation of a chemical process on earth materials. Okay, what are the different types of chemical process? Oxidation, reduction, hydration, hydrolysis, carbonation. Okay, these are different types of chemical process, and operation of these chemical process on earth materials is called as chemical weathering. Okay, see, and water, air along with heat must be present to speed up all the chemical reactions. Okay, now here see, what are all the 3 major factors that are responsible for to speed up chemical weathering? Water, air, and water, air and heat. Okay, these 3 are responsible or main factors for the chemical weathering to speed up. So we can see most amount of chemical weathering in areas having lots of water and heat, and along with the air. So water and heat, that is more precipitation and more like temperatures. So tropical forest region, you can see high amount of chemical weathering, and taiga region, high precipitation, so high chance of chemical weathering. Even savanna region also, high temperatures and not high amount of rainfall, moderate amount of rainfall, so high amount of chemical weathering. So we said operation of chemical process like oxidation, reduction, hydration, hydrolysis, carbonation, etc. If we look at examples of this, for example, if you take oxidation, wait. So for example, if you take oxidation, iron ore reacting with air. Okay. If you observe, if you take an iron rod and expose it to water and or expose it to air under sufficient amount of heat, rust develops on that iron rod. Okay. So similarly, this iron ore, we have iron ores in certain places, right? Rocks, iron ores are in the form of rocks in certain places. In those areas, if those rocks are exposed to sunlight and air continuously, okay, iron oxides are developed on those rocks, on those iron on those iron ores. Iron oxides are developed and they weather off, okay, and they strip off from that rock, and red soils are formed in that region. Okay, so in areas where there are more amount of iron ores, we can see the formation of red soils. Why? Because of the oxidation taking place for the iron ore. And similarly, if you take carbonation, okay, water reacting with carbon dioxide results in the formation of carbonic acid. Okay, and this carbonic acid, when it reacts with calcium carbonate, that is limestone, it results in the formation of calcium bicarbonate. Okay, when a limestone gets reacted with carbonic acid, it results in the formation of calcium bicarbonate. Calcium bicarbonate is easily soluble in the water. So whenever calcium bicarbonate is exposed to water, we can see different type of topographies in areas where limestone is present. Okay, what are those different types of topography we will see next chapter. And another example would be, like hydrolysis. Let's take hydrolysis. Okay, feldspar. Feldspar is present in granite. Okay, whenever it reacts with water, it develops clay. So the areas where granites are more, we can see the formation of clayey soils. Okay, so now you came to know how chemical weathering happens. Weathering happens and these soils are formed subsequently. Okay, this is chemical weathering. These are examples. Okay, and the second one is physical weathering. Physical or mechanical weathering, that is, there is no change in chemical composition in physical weathering, but there is a stripping of there is mechanical disintegration, that is stripping of the layers of the rock material. Okay, this physical weathering can happen through three mediums. That is, first is gravitational force. Okay, how gravitational force induce physical weathering? If you take rocks, the bottom layer of rock is covered by upper layer of rock. Okay, the bottom layer of rock is covered by upper layer of the rock, so it induces certain pressure on that rock. So okay, due to erosion or some other exogenic process, this upper layer of the rock got removed. Okay, it got eroded and the pressure gradually got released on the bottom rock. Whenever this high pressure gets released, gradually cracks are developed in this bottom rock, and it gets weathered and it gets stripped off. Upper layer get eroded and cracks are developed on this bottom layer or below layer, and whenever the cracks are developed, it gets stripped off. It is physical weathering that happens due to gravitational force. And second one is expansion due to temperature changes crystal growth. Expansion. See, in desert regions, we can see a high range of temperatures. In daytime, we can see high amount of like high degree of temperature, and when night time, it suddenly cools down. So, due to this continuous high temperature and low temperature, what happens means the rocks or the earth materials present in that region get expanded and contracted. Due to this continuous expansion and contraction, cracks are developed and the layers of the rock gets stripped off. So this is expansion due to temperature changes. See, expansion due to crystal growth means in coastal areas, uh, the rocks or earth materials are continuously hit by the sea waves. Okay, so whenever the sea waves hit the rock, the seawater gets gets accommodated or or enters into the pores of the rocks, okay, or holes in the rocks. So whenever the water dries up, the salt present in the in the seawater, uh, whenever the water dries up, the salt present in the seawater gets crystallized inside the rock. Okay, these salt crystals is present inside the rock. They get expanded and contracted due to temperature variations. Okay, whenever they get continuously expanded and contracted for over a long period of time, they develop cracks in that rock, and it is subjected to weathering. Okay, third one is water pressures controlled by wetting and drying cycles. See, you know, whenever yeah, in glacial regions or high latitude regions, the water freezes in the winter season, and after the winter season, the water gradually liquefies. Okay, whenever the water liquefies, it enters into the pores of the rock, and it stays in that pores of the rock. And during winter season, these water gets crystallized into ice. Okay, whenever it gets crystallized into ice, it expands and contracts due to these winter and summer cycles. The water molecules get contracted and develops into crystals, and again they get expanded and develop into water molecule in summer season. Due to this contraction and expansion of water cycle, cracks are developed in the rock material. That is physical weathering due to water pressures. See, many of these forces are applied both at the surface and within the different earth materials. Okay, if you take gravitational force, they act on the at the surface itself, and if we take expansion forces and water pressures, they exert their force within the material. Okay, the water seeps in within the material, expands, contracts, and then breaks it. Okay, yeah. Most of the physical weathering process are caused by thermal expansion and pressure releases. Thermal, we said, due to continuous insolation or incoming sun rays, the rock materials expand, and due to low temperature, they contract. This is one thing. And pressure release, that is gravitational, the upper layer rock erodes and releases the pressure, which develops the cracks. So these two are the main reasons for most of the physical weathering to happen. And next, biological weathering. Biological weathering, it happens due to living organisms. Okay, in chemical weathering, we can see chemical decomposition of the rocks. In physical weathering, we can see mechanical disintegration of the rocks. But in biological weathering, we can see removal of minerals and ions. That is, chemical decomposition is happening, and physical changes due to growth or movement of the organisms. So we can during a biological weathering, we can see chemical decomposition and mechanical disintegration also. Okay, examples of biological activity means burrowing and wedging by rodents, means rats, earthworms. Earthworms constantly burrow the soil, so that due to constant burrowing, different layers of the soil gets exposed to, you know, climatic factors, and weathering happens. So biological organisms are responsible for this. So it is biological weathering. Even due to agricultural activities, different layers of soil get exposed, or different vegetation is removed from the soils, so that soils become weak and weathering happens. Okay, and that is one thing. And another is through decaying plant and animal matter. See, these decaying plants and animal matter release certain type of acids into the earth, like carbonic acid, humic acid, etc. So rock materials present in earth means like in the surface itself, below the soil. Okay, they decay on the soil or below the soil. Whenever they decay, um, they release certain types of acids like carbonic acid or humic acid. So these acids, whenever they come into contact with the earth materials, they bring some changes in that earth material. So weathering happens. And as they are decaying plant and animal matter, it is a biological weathering. And plant roots. uh, how does roots operate? For a tree to grow, the roots also should penetrate deeper into the soil. When the roots grow and penetrate deeper into the soil, they hold on to the soil, and whenever they grow, they break the rocks present on their path, or in their path, so that we can see physical disintegration of the rock materials due to pressure exerted by the roots. Okay. Next, significance of weathering, sorry, effects of weathering. Weathering results in exfoliation. Exfoliation is not a process of weathering, it is a consequence of weathering, it is a result of weathering. What is exfoliation means? Exfoliation means flaking off of more or less curved sheets of shells from our rocks or bedrocks. Okay, exfoliation means flaking off. That is, flaking means, if you take a pencil and a blade, if you sharpen the pencil with the blade, you flake off the material on the needle part. It's called flaking off. So exfoliation, that is, layers get flaked off in exfoliation. Okay, and exfoliation occurs due to expansion and contraction induced by temperature changes. Due to sunlight, there is expansion, contraction, and because of this, exfoliation occurs. And significance of weathering. Significance of weathering. Weathering processes are responsible for breaking down the rocks into smaller fragments and preparing the way for formation of regolith and soils. Okay, weathering processes are responsible for breaking down the rocks into smaller fragments, and these smaller fragments were responsible for the formation of soils. How soil, soil forms or evolves, we'll learn subsequently. So weathering is a prerequisite for the soil formation of regolith and soils. Regolith means nothing but it is a primordial form of soil. That is the primitive, the first stage of formation of soils is regolith. Okay, but also erosion and mass movements. Okay, if weathering takes place, it it also speeds up the process of mass movement and erosion. So if a rock or earth material is already weathered, it is easy for it to slide down a slope, or it is easy for a water or wind to carry it. Okay, so it speeds up the process of erosion and mass movement. Forest depend upon the depth of weathering mantles. So more is the depth of the weathering mantle, that is the product, the more is the depth, the more is the rock layers get weathered, more the tree roots can penetrate. More the tree roots can penetrate, more favorable conditions for the formation of forest. Okay, weathering of rocks and deposits helps in the enrichment and concentration of certain valuable ores of iron, manganese, aluminum, copper, etc. Okay, uh, minerals occur in the form of ores. Okay, rock is nothing but we have different type of minerals in a rock. Okay, what is a mineral? One or more elements combined to form a mineral. Okay, uh, if one or more elements combine to form a mineral, we call it as a ore. Okay, um, sorry, one or more elements combine, it forms a mineral, and one or more minerals combine, it forms a ore. Ore means nothing but a rock. Okay, okay. For example, and weathering helps in the enrichment of the ore. Okay, if you take aluminium ore, that is aluminium ore is bauxite. What bauxite contains? Bauxite contains aluminium. Along with aluminium, it also has some oxides, some ions. Okay, through this weathering process, through chemical weathering process, so let's say in bauxite there are in certain bauxite ore there are 30% of oxides and ions and 70% of aluminium. Okay, it is before weathering. After the weathering, what happened? These 30% of oxides and ions got removed, and so after the weathering, what is the element that is more in concentration is aluminium. So it is called enrichment of the aluminium. So it and after this enrichment, it is easier for us to exploit these minerals, which is ultimately beneficial for the national economy. So weathering aids in enrichment. What is enrichment? Here it is given. See, when rocks undergo weathering, some materials are removed through chemical or physical leaching. Leaching means nothing but weathering. Another word is leaching by groundwater, and thereby concentration of remaining materials increases. That is, concentration of main materials increases due to weathering of certain materials on that ore. Concentration of important minerals get increased. Okay, it is called as enrichment. Next, second one is mass movement. After what weathering, we have mass movements. See, mass movement is nothing but these movements transfer the mass of rock debris down the slope under direct influence of gravity. So let's say it is a rock. What does mass movement mean? Transfer of mass of a rock debris down the slope under the influence of gravity. So okay, on certain materials, gravitational pull will be there. Okay, if the gravitational pull is stronger, these material or rock material slopes downward under the influence of gravity. It is called as mass movement. So for we have studied already, for weathering to takes place, what are the energy that is needed? Gravitational force, molecular stress, or chemical actions. But for mass movement, it is only gravitational force that is required for it to happen. Okay, the movement's mass movement may range from slow to rapid. If the gravitational pull is stronger, the movement would be speed. If it is slow, the movement would be slow. Okay, gravity exerts its force on all matters, both bedrock and the products of the weathering. Bedrock is nothing but rock that is not weathered is called as a bedrock. A bedrock that does not go any exogenic process, okay, is called as a bedrock. That is fresh rock or parent rock. Okay, different terms for that. So bedrock is nothing but a rock which did not undergo any exogenic process. Okay, gravitational force can be exerted on a bedrock also, and gravitational force can be uh, present on a weathered rock also. Okay, so whether the rock is weathered or not, gravitational force still acts on it. So weathering is not a prerequisite for the mass movement to happen. Here, see, weathering is not a prerequisite for mass movements. Why? Because gravitational force can act on a weathered rock and also on a bedrock also. That is, the rock that is not get weathered is called a bedrock. But mass movements are very active over weathered slopes rather than unweathered materials. Rather than on bedrocks, the mass movements are rapid on a weathered one because it already got deformed. Okay, it is already disintegrated or its chemical bonds might get loosened, so that it is easier to move that material rather than if it is unweathered. And mass movements are aided by gravity, and no geomorphic agent like running water, glaciers, winds, waves, and currents participate. That means mass movements do not come under erosion. Okay, weathering does not come under erosion because why? In weathering we cannot see transportation of materials. Likewise, mass movements also does not come under erosion. Why? Because here for the mass movement to happen, the gravitational force is necessary, but not geomorphic agents like wind, water, waves, currents, etc. See, materials over the slopes have their own resistance to disturbing forces and will yield only when force is greater than the shearing resistance of the materials. See, rock, it is a rock, for example, it is a slope. Okay, materials over the slope, that is the rock materials that are on that slope, have their own resistance to the disturbing forces. It is a slope and a rock materials are present on it. They have some resistance, that is they have some gravitational strength inside them to be like that. Okay, to be like that in a place, they have some internal resistance. Okay, um, and they have some like internal I don't say resistance, they have internal strength to be on that place. Okay, and while they're in that place, they offer their own resistance to disturbing forces. Here disturbing forces is what? Gravitational force. It is trying to pull. Okay, the gravitational force is trying to pull, but the rock material present on the slope offering some resistance due to internal strength present in it. That internal strength is defined by its chemical nature, physical characteristics, density of the material and all. Okay, so it has some internal strength, and that internal strength is offering resistance to the disturbing force, that is gravitational force. And and will yield, sorry, will yield means move. That material will only move only when the force is greater than the shearing resistance of the materials. The resistance offered by the material is called shearing resistance. Okay, because um, the resistance is like is not making it to breaking it into parts or move, so it is called shearing resistance. Whenever the gravitational force is greater than that shearing resistance, the material moves. Okay, there is a material here, there is a material here, it is offering resistance. Whenever the gravitational pull is stronger than the resistance offered by it, the material starts moving down. Okay, and next, what are the conditions that favor mass movements? Weak weak unconsolidated materials, thinly bedded rocks. Unconsolidated material means that are not strong enough to hold to one another are called as unconsolidated. And thinly bedded rocks that have less density, faults that are cracks, vertical cliffs. Vertical cliff means more slope, so more are the chances for the material to drop down or move along the slope, or steep, vertical or steep. Abundant precipitation, that is rainfall. If there is more rainfall, the materials get loosened and they move down. Okay, and torrential rains. Torrential rains means sudden rainfall. Okay, and scarcity of vegetation. If there is more vegetation on the slope, if there are more trees and plants on the slope, there will be more friction. Once the material moves down, if there is more vegetation, it gets stopped because these vegetation stops them in the middle. It offers friction for the movement. If there is no vegetation, there will be less friction and the movement happens down the slope. Okay, these are the favorable conditions for mass movements. And activating causes precede mass movements. That is, these the causes mentioned here, they trigger mass movement. Okay, they do not favor, they trigger. Okay, they make the mass movement to happen. First, these the ones that are mentioned here. First, these things happen, and after that, mass movements will happen. I mean, takes place. Okay, yeah. What are those activating causes? We look into it. Removal of support from below to materials above through natural or artificial means. Okay, there is a rock. Okay, and the rock is placed on a soil. If we dig here at the juncture, that is the point of contact between the soil and the rock, if there is disturbance that happens here, there will be mass movement of the rock material. That is one thing. Increase in gradient and height of the slopes. More is the slope, the height of the slope is increased due to any natural event, or due to any crustal movement, or any crustal movement, or any artificial means. If artificial means, if the slope increases, the material downfalls also increases. Overloading through addition of materials. Um, Due to rainfalls, or due to any transportation activity, the rock materials, there is addition of materials will take place. More is the weight, the stronger is the pull. So stronger is the pull, more is the chances for the mass movement to happen. So overloading of additional materials naturally or by artificial filling. Overloading can also occur naturally, that is through heavy rainfall also. Removal of material or load from over the original slope surface. Okay, it is a rock slope surface. There are materials here. See, okay, there are materials here. If you remove these materials, the pressure is released. Once the pressure is released on the slope surface, cracks are developed, and it is easier for it to, uh, you know, uh, move down the slope. And occurrence of earthquakes, explosions. Due to earthquakes or explosions, there might be, addition of materials. There can be difference in the slopes, so it causes mass movement, or it triggers mass movement. Excessive natural seepage. Seepage means getting into. Okay, getting into. See, if the groundwater seeps into the rock materials, it decreases the internal resistance of the rock material. Those rock materials are solidified together. Whenever the groundwater seeps into it, okay, what it does, it decreases the contact between the rock materials inside, and it will be easier for it to move under the influence of the gravity. So because the resistance decreases, so it moves under the influence of gravity very easily due to natural seepage. And heavy drawdown of water from lakes, reservoirs, rivers. Okay, see, um, yeah. There is a rock material and a river flowing on it, a river flowing it on a continuous manner. So what happens, this um, this river is exerting some pressure on that rock material. So because of this pressure, this rock material is not coming under the influence of gravity. Okay, or it is offering resistance to the gravity. If you draw down the river water continuously, okay, um, the the outflow of the river becomes slow. The rapid flow of the river becomes slow, and pressure exerting on this rock materials becomes less. So the rock material present beneath that river water gets under the influence of gravity and you know moves in a much more faster way. And indiscriminate removal of natural vegetation. Less natural vegetation, less friction, more is the movement. Yeah, and this mass movement, it will happen in three ways: heave, flow, slide. The three forms of mass movements. Okay, we'll look into one by one. Slide. What happens in a slide means, okay. Okay. Due to above mentioned causes and triggered conditions, we can say mass movement, and this mass movement happens in three ways: slide, fall, heave. What happens in a slide? Whenever a mass movement happens in a slide, what happens means, these rock materials, this bottom part of the rock is ahead while moving. See, the bottom part of the rock is ahead, it is in this direction. The upper parts are behind. That happens in a sliding. Okay, this is what sliding means. And next, fall. What happens in a fall? In a fall, the upper part of the rock that is undergoing the mass movement, the upper part will be ahead and lower part will be behind. Okay, so what happens here? Rolling happens. See, it is the upper part is ahead and lower part is behind. It goes like this, and again upper part will be see, upper part is like this and lower part is behind. Okay, it goes like falls like this and go ahead. uh, it just rolls in a downward manner. And next, heave. This fall and heave. What happens in a heave? See, in heave, the rock material, it slides down very slowly due to expansion and contraction. Okay, see, due to sunlight, the particles will expand, go up and come down. The initial, the particle is here, and due to expansion contraction, it is here, and from here again expansion happened, it went like this. Again contraction happened, it came down like this. Again expansion happened, it went like this, and due to contraction it came like this. So there is a movement of the material down the slope due to expansion contraction. It is called as heave. Okay, and there is a figure regarding this heave, slide and fall. It is not given in this PDF. Yeah, I will show it to you. I will explain this figure to you. Wait, see. In this triangle, see, flow happens in a wet region. Flow is at wet. Okay, so flow happens in a wet region. What are the examples? Mud flow and earth flow. Earth flow is nothing but rocks. Earth means nothing but rock. Rock flow that having substantially wetter particles in, that is substantially wet, will be flowing. It will not slide or heave, it will flow. Okay, and slide is happening in dry regions. So the land mass or rocks that are comparatively drier, that have less, what do you mean, uh, uh, less moisture particles, will undergo sliding. Examples are landslide and rock slide. And heave is a and again, sliding is a very fast movement. Okay, and once we go from slide to heave, the movement of the particles is less, that is slow. In heave, slowly, talus is nothing but the composition of all the boulders and rocks is called a talus. Talus creep, soil creep, creep or heave, both are one and the same. Okay, it is a slow process and it is also dry in nature. See, it falls under this dry region. So talus creep, soil creep are slow and are dry, and solifluction. Solifluction is also slow, that means it undergoes heave, and it is here the soil particles are substantially wet. Okay, in solifluction is a heave process where the soil particles are substantially wet. Okay, in rock slide and landslide, the materials are dry and it is fast. Okay, in flow, that is river flow, mud flow, earth flow, the particles are wet, substantially wet, and it is neither fast or slow, it is a medium paced. This is what this diagram depicts. Okay, yeah. So that's all for today, guys. Make sure you revise it properly, all the statements and all the diagrams that I have mentioned. Okay, in next class we will see landslides, different types of landslides, and why in India, why certain landslides happen in Himalayas and certain happen in Western Ghats. After that, we will see erosion and formation of soils. Okay, yeah, we'll meet in next class. Thank you.